Alright guys, the next property of exponents we're going to look at is going to be very similar to the last one. This one is called power of a product property. They'll get a little confusing, but when you use them, they're very, very distinct. So they sound a little similar, but they're very distinct in their properties. Here's your example here with some variables. So we have AB inside of your parentheses, and they're both taken to the power of n. What you're seeing is that both of these terms now have the power of n. Let's look at a number example. So just here, just same thing, the only difference here is it has that multiplication sign in between it. Both of these numbers are taken to the power of 5. Now our bases did not change here because they're different. Same thing here. Our bases are staying the same, so the 23 is being taken to the power of 5. This 17 is also being taken to the power of 5. So it's important to know that your bases stay the same because they're not the same. Because they're not the same bases. So let's look at some examples. All right, for letter A, it's very similar to the example that we saw above. Now up here, I just want to remind you that what we learned earlier was when the base is the same and we multiply across, we add our exponents. Power to a power, we multiply them, okay? Here, we're going to distribute almost that power to two separate bases. Yep, or sometimes more. So right now, inside our parentheses, we have the base of 34. It doesn't have a power right now, and we have the base of 9. Both of them are going to get that power of 6. So I'm going to throw that on right there. If you choose to throw it back in parentheses, you can. You don't have to, though. All right, that's simplified. We're good. All right, for the next example, we have 3 different bases here. That's really important. Whenever I see a base without a base without an exponent, I like to put a 1 in. That just helps me remember that when I take a power to a power, I need to multiply those numbers. So this technically has a base of 1, and this n technically has an exponent of 1, excuse me. So when we distribute that power, remember power to a power, we multiply. So the first base is a 4, 1 times 3 gives me 3. The second base is the m, 2 times 3 is going to give me 6. The third base is the n, which has the exponent of 1, so 1 times 3 gives me 3. Now, when a number is that small, sometimes it would be best to simplify that, but as you can see here, we're not asking you to simplify those, so I'll just keep it right like this. Let's look at our next example. We have 2 bases here. The first is the -2. Remember, that sign stays with the number. The g is the second base. So power to a power, we multiply. Keep the -2 in parentheses because we want to make sure that negative stays with it. That's going to be taken to the 4th power. 1 times 4 is 4. And then g to the 4th power as well. Again, this is a number I'd probably put in my calculator to make sure I simplify. But for now, I'm just going to show you the general rule. All right, last one. So this one's a little bit different. Just think about your rules. That negative is outside of the parentheses, which means that that 2 is not going to be distributed to that part of the expression. Again, 2 bases here. So this 2 is going to both of them in there. So I'm going to have 5 to the 2nd power and x to the 2nd power. Now I'm going to bring down that negative symbol. All right. And the reason why I'm going to put it on the outside is because I'm going to need to square that 5 before I bring down the negative. So 5 squared is going to give me 25. And then I still have x squared, but now I can bring down that negative. Excellent. There's some on the bottom for you to try. They match and are very similar to the ones we just did. So go ahead and give those a try.